Hello, today's topic, solving systems of linear equations by substitution. Essential question, how do you solve a system of linear equations by using the substitution method? Let's get rolling. First up, substitution. This is a method for solving systems of equations. Different than graphing, which is what we've done. This method involves solving one of the equations for either variable and then substituting the solution into the other equations. You need both equations to solve. Here's the steps that you can follow that'll help you get the job done. Step 1, when necessary, solve at least one equation for one variable. That means if an equation does not already have an isolated variable, you need to do that first. Step 2, substitute the resulting equation from step 1 into the other equation to find the variable. Step 3, substitute the variable from step 2 into either equation and solve for the unknown variable. Lastly, step 4, write the solution as an ordered pair that is like an xy point. What does x equal, what does y equal, or whatever the variables are that we're solving for. Before we move forward, there are some no solutions to systems. If you solve a system of equations and end up with a false statement, for example, 3 equals negative 2, that's not true, we say there is no solution. That means there is no value that works. For infinite solutions, if you solve a system of equations and you end up with a true statement, such as 3 equals 3, then we say there are an infinite number of solutions. I know that's a lot, but it kind of makes more sense once we do an example. So let's move on to example 1. Here we have the system x plus 3y equals 15 and x equals 2y. Notice that the second equation is already solved for x. We already have x isolated. That's a clue. We're going to use this. So we want to substitute 2y, since x equals 2y, into the first equation. We're going to take that 2y right there, and we're going to put that in for that x. Looking at that, we get, instead of x, 2y plus 3y equals 15. Now we want to solve like normal, meaning we're going to combine like terms. 2y plus 3y is 5y equals 15. Then we want to divide each side by 5. Divide the left by 5, divide the right by 5. That'll give us y equals 3. Now that we know what y is, we want to substitute 3 for y into either equation to find x. Once you know one variable, you could plug it into either one. I'm just going to use this second one since it's a little simpler. That gives us x equals 2 times y, which we know is 3. Then we just simplify, and x equals 2 times 3, which is 6. Now that we have both x and y, we're going to write the solution as an ordered pair. That's xy, or 6, 3. And that's our answer. If we wanted to, we could plug that back into each of these equations and test out, make sure that we didn't have any solving errors. That's our answer. Moving on to example 2. If you flip your page over, we got the same instructions solving this system, y equals 2x plus 1 and 3x plus y equals negative 9. Notice that the first equation is already solved for y. We have y equals 2x plus 1. So what we're going to do, since we know what y equals, is put that into the y of the second equation. Substitute 2x plus 1, that's y equals 2x plus 1, for y into this second equation. And that's what we've done here. Instead of 3x plus y, we have 3x plus 2x plus 1 equals negative 9. Whoops. For y into the second equation. After we've got that, we're going to combine our like terms. That's 3x plus 2x is 5x plus 1 equals negative 9. Then we want to solve like normal, subtract 1 from each side. So if we minus 1, that goes away. Minus 1 over here, we get 5x equals negative 10. Lastly, we want to divide each side by 5 to isolate the variable. Divide by 5 here, we're left with x. Divide by 5 here, that's negative 10 divided by 5 is negative 2. Now that we know what x is, we want to now plug that into a different equation. We're going to substitute negative 2 for x into either equation to find the y. Again, you could pick any of these two equations up here that you want. We're going to go with the first one, y equals 2x plus 1. Y equals 2 instead of x, negative 2 plus 1. Then we can simplify. 2 times negative 2 is negative 4. And then adding that 1, we'll get y equals negative 3. And that's simplifying. Once we found x and y, we have our solution. And we want to write that solution as an ordered pair, just like we've done here. Negative 2 for x and a negative 3 for y. And our final example, example number 3. Again, we have the same instructions trying to solve this system. X plus 2y equals 6, and 3x minus 4y equals 28. Now this one's kind of interesting. Since there is no isolated variable, we need to work on that first. What that means is there's not a variable by itself yet. We don't have an x equals or a y equals, so we need to make that happen before we could move forward. Let's solve the first equation. Since x is the coefficient is 1, and it is the easiest. See how we have this x kind of alone over here, just this plus 2y? That's going to be the easiest one for us to solve. Whenever there's a coefficient of 1 or no number directly next to that variable. So we'll take that equation, x plus 2y equals 6. And if we subtract 2y minus 2y minus 2y, keeping balance, that's going to move that 2y to the other side, and we'll get x equals 6 minus 2y. And that's what we did there. Subtract 2y from each side and simplify. Next step, we want to substitute 6 minus 2y for x into the second equation to find the y. So now we know what x equals. Let's plug that into our second equation for x right there. So instead of 3x, we get 6x minus 2y. Then we have the minus 4y equals 28. Now we just want to solve like normal. Let's distribute, since we have those parentheses there. 3 times 6 is 18, minus 3 times 2y is 6y. Distributing that out, multiplying. Then we have minus 4y equals 28. After that, we want to combine our like terms. We've got a minus 6y and a minus 4y. Those are like terms to give us a negative 10y. So we have 18 minus 10y equals 28. Then we want to subtract, Then we want to subtract 18 from each side. So if we subtract 18 from the left, that goes away, leaving negative 10y. If we subtract 18 from the right, 28 minus 18 is 10. We're almost there. Now we just want to divide each side by negative 10 to isolate the y. Divide by negative 10, we'll just be left with the y. Divide the right side by negative 10. 10 divided by negative 10, we'll get a negative 1. Now we know what y is. We're going to do those same steps by substituting that negative 1 into the first equation and simplifying. Again, you could put that into either equation, but sometimes we just choose which one we think is going to be a little easier. In this case, we chose the first equation, x plus 2y equals 6. So we have x plus 2 times y, and instead of y we put in negative 1, equals 6. After we simplify that out, that's just 2 times negative 1. That gives us a plus negative 2 or a minus 2. So we have x plus negative 2 equals 6. Let's add 2 to both sides. In order to isolate that x, those 2's cancel out. X equals 6 plus 2, which is 8. Finally, since we solved for x and y, we want to write the solution as an ordered pair, which we've done here. X is 8 and y is -1. All right, take a few minutes and write a quick summary about how we can solve systems of equations using the substitution method. Look back up at the steps, look back up at the examples, but make sure you're explaining what you're doing in this process. It'll help you remember. I hope this was helpful.